In this video, we're going to talk about relations and functions. A relation is when you have a set of ordered pairs. A set of ordered pairs. And ordered pairs are written in the form parentheses x, comma, y. X is the input. So the x values are the inputs and the y values are the outputs. The domain are all possible inputs of the relation. So all possible inputs of the relation. So we can say possible, we can say allowable, all the inputs that are allowed. And the range are all the possible outputs. All possible outputs. So once you put all the allowable inputs in, all the corresponding outputs become members of the range. So here we have an example of a relation. We have ordered pairs 1, 4, 2, 8, 3, 12, and 4, 16. So we have 1, 4, 2, 8, 3, 12, 4, 16. 1, 4, 2, 8, 3, 12, 4, 16. So what I'm doing is I'm just going to rewrite this using color so that you can clearly see that all the possible inputs of this particular relation, separate those by commas, and then we have braces. We have 4 ordered pairs in this relation. The domain we list from least to greatest. So the set, that's what the braces mean, the set of the numbers 1, 2, 3, and 4. So least to greatest, no repeats. Least to greatest, no repeating. And our range is the set of all numbers 4, 8, 12, 16. They're individual elements, 4, 8, 12, and 16. And again, that's least to greatest with no repeats. And that's our domain and our range of our relation. For the following relation, the input x is the age of boys and the output y is their corresponding height in inches. Now this is where I like to use a table. So I'll use a table of values to list my x and my y values. And I have 7, 41, 8, 45, 9, 49, 10, 52, 10, 53, 11, 55, and 12, 59. So this is another way that you can show your relation. X is my age in years of boys and y is my corresponding height in inches. I'm going to put in inches here. I also like to use a highlighter. So sometimes I'll highlight the input x is the age of boys, 7, 8, 9, 10, 10, 11, 12. And then the output y is their corresponding height, 41, 45, 49, 52, 53, 55, 59. So sometimes I use color to bring out the picture. And I want to plot these points on the graph. So here I have my graph, and I'm going to plot these points. So I had 741, that's that point right there. I have 845, 949, 1052, and 1053. I'm going to have to make room there. Then I have 1155, so I might have to go back here and make this very thin. So let's do this. So we had 949 and then 1052 and 1053, and then we have 1155, and then we have 1259. There we go. It's a little bit better. Now this right here is not a continuous graph. This is a discrete graph. So this is a discrete graph. The age or year is the independent variable. And the height is the dependent variable. Height depends on how old you are. Dependent variable. How old you are doesn't depend on your height. Now what's happening here? There's a few things that are happening here. As age increases, height increases. What else do we notice? That at age 10, there were two different outputs. Age 10 had two different outputs, whereas the other ages didn't. So the boys that they measured here, they had two that were at age 10, but all the other boys were different age. The first age is a 7-year-old, and the last age would be a 12-year-old, so the oldest child is 12. So these are all different things that we can think of. There's not a constant rate of increase, but maybe a changing rate of increase. So we'll talk about that as well at another time, but we could be talking about the rate of increase or the rate of change. And as the age increases, the height is always increasing. The younger kids are actually shorter than the older kids, which makes sense because that's the way it is most of the time. So let's take this. I showed you as a table. So we showed you as ordered pairs. We showed you as a table. Now I'd like to show you a mapping diagram. So a mapping diagram, you write least to greatest, again with no repeats, least to greatest, no repeats. So you write all the members of your domain in the box on the left and all the members of your range, the box on the right. I'm going to use those same colors I used before. So the one on the left is my domain and the one on the right is my range. The mapping diagram, when I had a 7-year-old, the 7-year-old was 41 inches. Notice how we start with a point at the 7-year-old and it draws an arrow to the 41 inches, which would be an arrowhead. So the arrowhead goes on the range. An 8-year-old, you put in an 8-year-old and you get out 45 inches. That arrowhead is very important. 9-year-old, 49 inches. 10-year-old, there were two of those, One was 52 inches, the other one was 53 inches. The 11-year-old, 55 inches, and the 12-year-old, 59 inches. And that's a mapping diagram. The domain, again, we're going to list the numbers from least to greatest with no repeats, just like the mapping diagram. And the range, least to greatest, no repeats, 41, 45, 49, 52, 53, and 59. So something for us to think about is 10 occurring twice. Let me go back here real quick. 10 occurring twice, there were 2 arrows coming out of 10. So we didn't repeat listing 10, but there were 2 arrows coming out of that repeated value in the domain. Okay, let's talk about a function. A function is a type of relation. It's a type of relation in which there's only one output for every input. Type of relation in which there is only one output for every input. And remember, inputs are your x values for every input, meaning that x values are only used once, so they are used exactly one time. That's important for a function. So important, I'm going to take out my highlighter and I am going to highlight that. X values used exactly one time. That's what makes a function. So give the domain and range of each relation, state the corresponding outputs for the given inputs, and explain whether the relation is a function. This is a table of values. When you put in 40 students, you get out 2 classrooms. So this is the number of students, and your y value is the number of classrooms. So sometimes I will write this. I wish I could cut and paste this right now. Sometimes I will write this as an ordered pair. I can do that. I can rewrite this one, and I'll show you the ordered pair that I want to write, comma, comma. My number of students is 40, so I put in 40 and I get out 2 classrooms. I put in 45 and I get out 3 classrooms. I put in 50 students and I get out 4 classrooms. Our domain is 40, 45, and 50, and our range is 2, 3, and 4. This is a function because each member of the domain, 40, 45, and 50, is used exactly one time. So this is a function. Okay, let's try another. The given relation represents the amount of gas in gallons and the distance traveled in miles from that amount of gas. So when we have 10 gallons of gas, we travel a distance of 150 miles, 16 gallons of gas, 240 miles, 17 gallons of gas, 240 miles, 20 gallons of gas, 300 miles. So we have 10, 150, we have 16, 240, 17, 240, and 20, 300. I like to make a mapping diagram. My domain is 10, 16, 17, 20, and my range is 150, 240, 300. So remember, least to greatest, no repeats. 10 goes to 150, 16 goes to 240, 17 goes to 240, and 20 goes to 300. Every member of the domain has exactly one arrow coming out of it, meaning it is only used once. I do not repeat any of my x values. Therefore, this is also a function. It's all about the x values when we're talking about a function, not the y values. Therefore, this is indeed a function. Now we can test to see if we have a function by using the vertical line test. The vertical line test, you may remember, is used to see, meaning this is a graphical representation, if any given x has more than one output. Has more than one output. And it's called the vertical line test. So let's use the vertical line style. There we go. I'm going to make it red. Oops. I think that'll work. Let's see. Okay, let's see. Right there. There we go. It's just been a while. There we go. So there, I'd like to use that vertical line right there. And now I can use my vertical line test to see if each relation is a function. So as long as my vertical line passes through the graph, so this is a graph that's a curve. Let me draw it for you. So here's my graph. This blue graph, we want to determine if it's a function. So we take our vertical line, and as long as I don't pass through the graph more than one time at any given point, it's a function. Number 6 is indeed a function. Let's look at number 7. Number 7, using the vertical line test. So I'll come over here and I'm going to go from right to left. Right here, it passes the vertical line test because it only touches the graph once. But as soon as I move to the left, you can see that it intersects the graph more than one time. As soon as it intersects the graph any place more than one time, it is not a function. So the graph on the left is a function passing the vertical line test, and the graph on the right is not a function. It fails the vertical line test. And that concludes our lesson for 2.2, and you can see that in the next video we're going to be looking at 2.3.